Welcome to this theory lecture about continuous integration and continuous delivery. This is the final theory lecture of the course Introduction to DevOps. Here is the contents of this lecture set and the agenda. So first of all, we will discuss what is continuous integration and delivery. Then we will move on to see how it relates to DevOps as a concept as a whole. Then we will see how to build a automatic pipeline that performs the continuous integration and delivery practices. After that, I will present some tools and integrations that can be used to develop some pipelines, for example. And finally, I will visualize an example of CI/CD pipeline, which will give you a clear understanding of the CI/CD process. So, first of all, let's start with continuous integration. So, according to Martin Fowler, continuous integration is a software development practice where members of a team integrate their work frequently. And usually each developer integrates at least daily. So, now the term integration means to essentially merge the software or the updates that the developer has been doing into the main software source code. So if we are thinking about in terms of version control, it means that the developer will update his or her changes to the version control repository daily. And it can even happen more frequently, and especially, like Fowler says, leading to multiple integrations per day. If there are multiple developers in a team, which is usually the case, then all of the developers will integrate their work daily, which will lead to a lot of integrations. Now, because this integration happens a lot during the day, it is really important to be automated. So that is the idea of the automatization of continuous integration. And well, the definition by Fowler continues that each integration is verified by an automated build. So this refers to an automated process that will check that the code is relevant and can be integrated into the software existing source code. And testing is a really important part of continuous integration, since testing will make sure that the updates to the software will work as intended. So without testing the updates, it would be really unreliable to automatically update the software. It could break really easily if the developer has made some kind of a mistake that leads to some problems on the software. So the testing is really key concept in continuous integration, and the software must be tested in order to automatize the process. And finally, Fowler states that many teams find that this approach leads to significantly reduced integration problems. So it refers to the testing and also the continuous integration as a whole. When the process is such that it tests the updates and then integrates it into the software automatically, it really makes the work of the software developers more easy. They don't have to manually see that everything works and try to solve the possible all kinds of situations. The pipeline or the integration that happens automatically really makes the development work more easy and effective. So next here is definition of continuous delivery by Martin Fowler. So he defines that continuous delivery is a software development discipline where you build software in such a way that the software can be released to production at any time. So compared to continuous integration, where the goal was just to integrate the updates of the source code into the main line of development, for example, the master branch on version control. In continuous delivery, the goal is to actually publish the changes of the software to the end users of the software. So this is kind of a continuation to the CI. And usually this continuous delivery isn't done without a continuous integration practice. So like it is even more important to verify that the software works correctly when it is automatically published to the users. There is no room for mistakes, and any bugs will automatically, if there were to be any bugs in the software, they would be apparent to the users and the software might break and things like that. So it is really important to have a good testing procedure in order to practice this continuous delivery. And like Fowler defines, continuous delivery is achieved by continuously integrating the software. So having the previously mentioned continuous integration done and other stages of continuous delivery can include, for example, building the executable of the software, running automated tests on those executables. So the testing kinda is present on both continuous integration and deployment, and software testing as a whole is a really big concept. So it cannot be placed strictly on some place. Like it needs to be present as much as possible in order to make sure that the software works. And finally, Fowler states that the executables are pushed into production environments, and the idea is to ensure that the software will work in production. And well, this statement doesn't necessarily mean that the end users would be using the software, but the kind of the ultimate way of doing continuous delivery would be that the software is actually published to the environment where the customers and the users of the software will be using it. But it is also, like Fowler states, it is possible to have continuous delivery in such a way that it isn't necessarily accessible by the end users of the software, but maybe just the developers. It still makes the development work easier, but the kind of the most efficient way to do continuous delivery would be to automatically publish the software to the end users. And finally, Fowler mentions the deployment pipeline, which essentially is an automatic process that will make and perform the stages of continuous integration and continuous delivery. So let's next talk about continuous integration and delivery and how they relate to DevOps. So DevOps is the key term on this course, since this is Introduction to DevOps, and it means the set of practices that enhance the cooperation between the development and operations of a software product. So usually and traditionally in big software systems, there is a separate team for the software development and separate team for operations and maintenance of the software. So DevOps has emerged kind of from the conflict that happens between the development and operations team, as they have a different kind of needs and desires regarding the software. The development team usually wants to publish and change the software as much as possible in order to fix bugs and produce new features and enhance the software in whatever ways. And the operations team, on the other hand, wants to have the software stay as static and as not. They don't want to change the software, since it can mean that it would be harder to maintain. It can mean that the software needs to be updated to some customers, and it essentially means more work to the operations team. So the development team wants to change the software as much as possible, while the operations team wants to have the software as not change. They don't want any changes to the software if they are asked. So this is where the concept of DevOps has come to life, and the idea is that the wants and needs of the development and operations teams are tried to have. DevOps is a kind of a culture that tries to unify these teams by the development and operations team by having a set of practices that make the work of both of the teams easier. So now when we think about continuous integration and continuous delivery, which essentially make it easier to first of all change the software and also to publish the software. So this kind of solves a problem for both of the teams and makes the life of the developers more easy and makes the life of the operations team more easy. So CI/CD therefore is a concrete way to practice the DevOps culture, if I may say. And finally, like it was mentioned before, the continuous integration and deployment can be implemented with pipelines. So the term pipeline is used for a process that performs the continuous integration and delivery. So it might be hard to grasp the concept right now, but it will come more clear once I show you some visual graphics regarding CI/CD pipelines. So here we have an example pipeline process, and this is probably the most common CI/CD pipeline process, which has three different stages. So the first phase or stage is this build stage, and the goal here is to build the software, and whatever is the software technology, there might be different kind of processes that need to be made in order to have the software be ready to run. For example, some Java Spring applications the build process might include making the executable jar file, and so that the build process would then include the building of the jar file that can be executed in the Java runtime environment. The second stage commonly is the testing stage, and as I mentioned before, testing is really a key concept in both continuous integration and continuous delivery. The goal is to ensure that no broken changes get made to the software, and that is the goal in continuous integration. And in continuous delivery, the goal is to make sure that no broken version of the software gets deployed to the production environment. So testing is therefore a really key phase in this CI/CD pipeline. And finally, the deploy stage, it relates to the continuous delivery solely. So the goal there is to deploy the application to the environment that it is wanted to be deployed into. So it can be some kind of a testing or staging environment, or even the production environment where the customers will be able to access it. So it depends on the situation, but the goal of the deploy stage is to have the build and tested software deployed into some kind of an environment. And now it is very common to have this pipeline run automatically when a certain event occurs in the version control. So the pipeline also can be run manually usually, but the most effective way is that the pipeline is automatically triggered when, for example, a software developer pushes or merges his or her changes to the main branch of the software. So that is even more, or that is the most effective way to run the pipeline. Also, it is very possible to automatically have the process be manual, so that when the developer merges his or her code, there can be some kind of a button that triggers the pipeline, but the kind of the most and best option is to have the pipeline run automatically. And nowadays the version control systems like, for example, GitLab.com have a really good CI/CD support, so the version control system and the CI/CD pipeline can communicate with each other, and the version control system can basically tell the CI/CD pipeline when some kind of an event has been happened in the source control and or the version control. We will discuss this more during the next slides. Okay, and when you start to implement a CI/CD pipeline, so essentially an automatic process that will build, test, and deploy the application or the software, you need to have the pipeline interact with two different entities. First of all, the version control system. And this is important because the CI/CD pipeline needs to know when a certain event has been made to the version control. For example, if the pipeline is wanted to be run when the main branch of the version control is updated, then the pipeline needs to know when the main branch is, when a push or a merge event has happened to the main branch. This communication can be done with various ways, for example with webhooks or even ready-made integrations. Certain tools integrate very well with existing version control providers and have this communication set up automatically. The second thing the pipeline needs to be able to interact with is the runtime environment, the environment where the software is wanted to be deployed. And this is because in the deploy stage the goal is that the pipeline will deploy the software, so therefore there needs to be some kind of a way for the pipeline to essentially deploy the software, which can, for example, mean putting the newest executable of the software into the production environment. For example, in the case of a Java Spring application, the pipeline can bring the newest Java file into the Java runtime environment that is in the production server. So these two lines of communication are very important when implementing a pipeline in practice. Now a little bit about the tools and integrations that can be used when developing these pipelines. So first of all, to list some CI/CD pipeline tools, there are GitHub Actions, GitLab CI/CD, Circle CI, Jenkins, and many more like PuTTY CI, for example. The first two are maybe especially interesting because, as we know, GitLab is a version control provider and GitHub is as well. So these CI/CD pipeline tools essentially are an extension to the version control system that these providers are offering. And this means that there is a direct integration between the, for example, the GitLab version control system and the CI/CD pipeline system. And as I mentioned in the previous slide, the communication between the version control system and the pipeline is essential in order to have an automatic CI/CD process. And in the case of GitLab, for example, the communication is handled with a direct integration, so there is very little manual work to be done in order to have these two entities communicate with each other. This will be demonstrated well in the practical section in this course. But like I mentioned, even when direct integrations are not available, there are different ways to communicate. For example, the webhooks and different kind of API calls, where the pipeline can be informed. The version control system, for example, can inform the pipeline when a certain event has happened. Or maybe the pipeline can also sort of poll the version control system and ask it periodically if certain things have happened. So there are many ways to handle this communication, but it is good to know that these direct integrations that I mentioned make the configuration of the pipeline more easy and efficient. So finally, let's talk about a concrete CI/CD implementation, and let's use the technologies that are present or are used during this course and are available to you. So let's assume that we have a Node.js based web application on GitLab, and let's try to deploy it to Microsoft Azure. So now we have a GitLab.com version control, and since there is the direct integration between the GitLab version control and the GitLab CI/CD pipeline tool, we can also use the ready-made pipeline tool by GitLab. So we have GitLab.com as the version control system, we have GitLab CI/CD as the pipeline tool, and we have Microsoft Azure as the production environment. And now the Azure and GitLab aren't directly integrated in the same way that the GitLab CI/CD and the GitLab.com are, but still it is very possible to deploy the software into Azure, and there even is there is some kind of integrations available, and we are able to deploy the software there. And there essentially is two options in order to deploy it when we take a look at the offerings by Microsoft Azure. So option A would be to deploy the application with the web app service and selecting the Node.js runtime environment on the web app service. So in this case, the Azure Web App Service we would input the source code repository on GitLab.com to the web app service, and then the service will deploy the application based on the source code. Option B would be to use the Azure Web App for Containers service, which is essentially in the same web app service but as a different option in the configuration there. So another option would be to containerize the application into a Docker container and then provide that container to Azure, which will in turn then deploy it into a Docker runtime environment. There are also, for this option B, some further options. We can use different container registries where the Azure will pull the container from, but that is also something to think about. But first, it is maybe the most important to decide between the option A and B. So let's next see this in a more visual way. So here is a visualization of the possible pipeline process or processes which have to do with the presented case on the earlier slide and the two options that I gave. So first of all, the pipeline will start when some kind of a change event happens in the GitLab version control. For example, if the master branch gets updated in a push or a merge event. Then the application can be built, and this was a Node.js application, so the build process will be done according to the software technology. After that is the testing phase. So now the goal of that phase is to make sure that the application works as intended and that it essentially that it is ready to be deployed into the environment, final environment. So then there was the two options, either deploy it to the Node.js runtime environment on Azure or deploy it to the Docker runtime on the same Azure service, the web app service. But before we are ready to deploy it into the Docker runtime, we need to first of all build the Docker image of the application and then push it to some container registry. And I presented the two further options, either GitLab or Azure. So this is up to the situation which one would be better, and when it is decided, then the goal is to deploy it finally into the web app service. So there are some options here that I presented, and there are even more options, of course, if, for example, more cloud providers would be considered, and even regarding the testing, if it wants it can be multiple stages, for example, if unit testing, integration testing, system testing, UI testing, if they want to be separated on the pipeline, it is also possible. So it is important to know that there are lots of different possibilities when implementing the pipeline, but the key takeaway is to first design a simple pipeline that does the process as well as needed, and then maybe on the future improve it further. But it is important to first implement a pipeline, sort of a minimum viable pipeline, and then improve on that, and at least find some kind of a balance between the pipeline development and other development. So this is a visualization of some of the possibilities regarding the CI/CD pipeline. Finally, here are the references that I used during this lecture. So the Martin Fowler's definitions were the main references, and also the pipeline tools websites and Microsoft Azure website has been used when making this material. Thank you for your time, and don't hesitate to contact the core staff if you have any questions regarding this topic.